to hours, and let's go my value add hours, and we'll add 3 hours to long time string, and that will be 6:38 p.m. Okay. And then what if I wanted to subtract time? Are there any subtract hours or subtract days? No. However, what you can do is simply use a negative number to subtract. So instead of adding days, I'll subtract days. And yeah, we'll just go ahead and run that. And you can see 3 days ago, it was Saturday, March 12th. Great. All right. So in addition, we can just grab off parts of a date or time. So here again, let's go, whoops. Let's go my value, and let's just pull off this current month, and this will return an integer. Now console.writeLine we know can accept an integer, so we'll just go ahead and print out the current month. So the third month, obviously that's going to be March. Okay. All right, now we've looked at how to create the current date time, but what if I wanted to create a date time in the past or in the future? I could do something like this. So date time, and I'm going to call this my birthday. And here again is that new keyword that I've hinted at a number of times. We will get to it. Don't worry, but I'm going to use it one more time. New date time, and I'm going to pass in the year 1969. The month, December, and then the day, the 7th. That was the day I was born. And so now what I can do is something like we've been doing up to this point, console.writeLine, and just my birthday, .to short date string, just to prove that it's a date just like the other dates that we've been working with. So 12/7/1969. All right. Now there's one final way to create a new date time, so let's create another version of birthday equals datetime.parse. Remember, we've used int parse. We were able to take a string and turn it into an integer. Here we're going to take a string and turn it into a date, hopefully. So we'll just type in my birthday again one more time, and that should give us a date time object that represents December 7, 1969. And now what I'm going to do is try to determine how many hours that I've been alive, or how many days I've been alive. Days is probably a more interesting number. And in order to represent a span of time, we're going to use a new data type called time span. So here I'm going to use a new time span, and we're going to call this my age equals datetime.now subtract, and the subtract method will take the current date and subtract whatever date we want to use. So in this case we'll use my birthday. Okay, so now that I have an object that represents a span of time, I can say represent that span of time in terms of days or years or whatever the case might be. So to do that, I'll go console.writeLine, and then I'll use this myAge dot, and here I can say give me the total number of days that I've been alive, and print those to screen. And you can see I've been alive, what, almost, well, 16,900 days. Whew. I'm getting old. Okay, I say that every time I record this video, and I feel older every time. So at any rate, here we were able to format dates for display. We're able to manipulate dates by adding and subtracting date and time, and then we're able to determine the difference between two dates using a time span object. We also talked about different ways to create a date, whether it be now or sometime in the past or future, by either just using one of the versions of the date time object's constructor, we'll talk about that later, or by using datetime.parse and passing in a string. Okay, so let's stop right there, and we'll pick it up in the next lesson. Doing great. See you there. Thanks. Hi, I'm Bob Tabor with Developer University. For more of my training videos for beginners, please visit me at devview.com. You might recall at the outset of this course, I said that a class is a container for related methods, and I used the console class as an example of this. We had the console.writeLine, console.readLine, console.write. We even used console.clear. All of these methods that had something to do with working with a console window, and so I said it makes sense to put them all in the same class, the console class. Now, truth be told, I intentionally oversimplified my explanation about classes and their relationship to methods because, first of all, I wanted you to gain a little bit of confidence in yourself that you can do this, that this isn't hard. You can get your hands around it and you're going to do just fine. And I wanted to do that before we got into the topic of classes because while there's nothing hard per se about classes, they do lend themselves to a conversation about object-oriented programming, a style of programming that some beginners find a little bit difficult to grasp at first. Now, the code that you've been writing in your methods have all been defined inside of classes, right? And you've been calling methods that were defined inside of classes, right? Classes have been all around you. You've been working with them up from the first line of code that you wrote. So you're really already an old pro at this, whether you realize it or not. I'm merely going to fill in some of the details that you don't yet know about in this lesson and in a couple of subsequent lessons so that it rounds out your knowledge so that you can fully harness the power of the .NET Framework class library in your applications. Yeah, okay, maybe someday, whenever you sit down to architect some big application for some large company that you go to work for, you'll begin to think like an experienced object-oriented software developer. But at this early point in your C# experience, I really just want you to be able to do one thing and one thing well. That is to find what you're looking for in the .NET Framework class library and be able to have the confidence to utilize the methods and the properties in those classes that have been defined there. All right. So the truth of the matter is that object-oriented programming is such a massive topic that I certainly couldn't do it justice in this course. In fact, I have a whole course devoted to it on devu.com. Again, I really just want to accomplish one thing here. I want you to know enough about classes and objects and properties and methods and things like that so that you can harness the power of the .NET Framework class library inside of your own applications. Now, the way that we're going to learn about classes and methods and properties and all that good stuff is by creating simple custom classes of our very own. So let's start by talking about creating a simple application for a car lot. So suppose that I own a car lot and I want to sell cars. And I want to build an application that helps me keep track of all the cars on my car lot. So I might need to create a number of variables to hold information about a given car because I'm going to use that information to then determine its value based on its make and its model and its year and so on, right? So I might start off by creating a couple of variables called car1 make, car1 model, car1 year, and so on in order to keep track of that information. Now, what if I need a second car in my application? Well, then I guess I could create another set of variables called car2 make, car2 model, car2 year. What if I need a third one? Well, I think you see where I'm going with this. Things are going to get out of hand pretty quickly here. Then what if I decide one day that the value of the car is not only based on the make, model, and the year, but we also need to keep track of the color of the car as well. So in that case, now I got to do a car1 color, car string, car2 color, and so on. All right, so you can see that this simply is not the right approach to keep track of information that should be collected together about a given entity. So I need a way to keep all of this data about a car kind of together in its own little container. I want to keep track of the make, the model, the year, the color, and maybe a bunch of other things too about a single car. But I don't want to have to treat it like a bunch of loose information. I need it all kind of related together. So what I'm going to do is start off by defining a class that contains 4 properties that describe any given car on my car lot. Okay, so to begin, what I'm going to do, you can see I have a project that I've already started with here, simple classes. Go ahead and pause the video and catch up with me if you like. And what I want to do is work actually outside of the first class that's already been defined in our program.cs file. So I want to work inside of the namespace simple classes, but I don't want to define a new class inside of my existing class. I want to work outside of that class here. And so I'm going to define a new car class like so. And I'm going to give it 4 properties, and I can type it all out like this, and I'll explain what I'm doing here in just a moment. Or I can use a shortcut, prop, tab, tab, and then I can use the replacement, the little replacement areas by using the tab on my keyboard. So I want to make a string, tab, tab, model, enter, enter, prop, tab, tab, int year, enter, enter, prop, tab, tab, string, tab, tab, color, enter, enter. Okay, so I've just defined a class named car with 4 properties. This car class allows me to define a data type that describes a car. Every car in the world. Every car has a make, a model, a year, and a color, and a bunch of other information that I might or might not be interested in for my specific application. But my aim here is to use this definition of what comprises a car in order to create additional instances of the car class that represent all of the cars on my car lot. Okay? In other words, I want to create a bucket in the computer's memory that's just the right size to hold information about any given car on my car lot. So it should contain not only the fact that it's a car, but then also the value of its make and its model and its year and its color, all kind of in one big bucket up in the computer's memory so that I can access it. All right. So there's 2 parts to this. There's defining the class itself, and then once I've defined it, I can create instances of that class. So here the class is the definition. But when I create a new instance of this class, then I'll be working with an object, and sometimes those terms get confused. But the class is the blueprint. The object is an instantiation or something that's been created as a result of having the blueprint or the pattern. Okay? So the way that we create a new instance of the car class is to do this. I'll just call this my car to avoid confusion. So at this point, I've defined it just like any variable I would by declaring the data type itself, whether it be string or integer. This is just a little bit more interesting, a little more complex. It's the car class. And then I give it a name that I want to call it by, my car. All right? Now that's part of what I need to do. The next thing that I want to do is actually then create a new instance of that class and say, put this up in the memory, in the bucket, so to speak. So here we go, new car. All right, so again, there's 2 parts of this equation. We'll talk about this more as we go throughout this, this course. But we're saying, first of all, I want to declare a new car in memory, and then I want you to actually create the car. I want to create an instance of car and then put it up in the memory. So there's 2 distinct steps there. All right. In the real world, you can use the same blueprint to create many different houses, right? You could, like in the neighborhoods that I've lived in before, you might describe them as cookie cutter houses. They all look the same. You could use the same pattern to create clothing over and over, or you could use the same recipe to create the same cake or casserole and get the same results each time. So each time you want to build a new house, it will be at a different address, right? Each time you follow the pattern, you'll create a new instance of the clothing that can be sold to a different customer. Each time you follow that recipe, you'll create a new instance of the recipe, and you can offer it during either the same meal or a different meal. All right? And the same is true with classes. Each time that you create a new instance of the class, you have a new object that is distinct and separate from the other instances of that same class in the computer's memory. All right? So they each live by themselves. So a class is like a cookie cutter. Now, keep in mind, you can't eat the cookie cutter itself, right? You eat the cookies that you make from the cookie cutter. The cookie cutter gives each of the cookies some shape. And so when you instantiate a new instance of a class, you're basically using your class as a cookie cutter to stamp out new instances, and you have 1, 2, 3, 4 new instances of cookies that you can then put in the oven and bake. All right. So focus on the new keyword. It is what you would consider to be the factory. It actually builds the new car and puts it into memory. All right. It uses the blueprint, it uses the pattern, it uses the recipe, uses the cookie cutter in order to create a new instance of that blueprint or that pattern or that recipe or that cookie cutter. And it brings the class to life in the computer's memory, and it makes it usable by your application. And you can create many instances of a given class, or you can create many objects all based on the same class, but each object will be distinct from the others, if by no other distinction than by merely the address in memory where they live. Okay, so what I want to do is not only set the properties of this car, because I have these 4 properties that I want to use to distinguish this car on my car lot, to represent this single car, but then also I may want to then access or get those properties back out. And it's working just like you're working with variables, all right? So in this case, instead of just accessing make variable, I would go mycar.make, right? And I would set that equal to like Oldsmobile. Now, admittedly, in this particular case, I am merely hard-coding these values. If this was a real application, I would ask an end user to input this information, or I'd grab it from a database or something along those lines. All right, so there we have it. We have one instance of the car class, and I've set all of its properties, and now I want to get those properties and print them out in a console window. And we'll just do this in the most easy way possible. And we access, or we get the values just like we set the values before, by using the name of the object dot the name of the property. So let's go make my car dot model, my car dot year, and my car dot color. Now you might be wondering, well, Bob, why did you do it that way and not car.make or car.model? Remember, car, in that instance, car, describes the class, the blueprint. But what we want to work with is one instance of the blueprint. So that's why we're calling that instance my car. It's the variable name in the computer memory that we want to work with. So let's go ahead and separate these out onto separate lines, and then finally we'll go console.readline, like so. And this should not be an exciting application at all, because we're merely just printing things to screen, okay? But at least I can show creating a new instance of a class, setting the properties, and then getting the properties and printing them out. So that's what this get and this set are for. And there are actually longer versions of to declare a property. In fact, let's just do this prop full tab. And so this is a longer, more complete version of creating a property, but I don't want to talk about it right now. There are reasons why you would want to use this, but for the most part, for our simple needs, we'll just use this abbreviated version of defining a property in our classes, okay? Now, did you notice that we got full IntelliSense support? So whenever I typed out my car dot, and I use the member accessor operator, that I'm able to see all the members of the class, the make, the model, the year, and the color, all represented as little wrench icons in IntelliSense, so that I can access them, whether to set their value or get their value. Okay. Furthermore, I'm able to set values the way that I would just with normal variables by using the assignment operator. Okay, I'm able to work with the variables and write them just like I would any other variable in my system. Okay, so there's nothing all that special about it outside of the fact that they're all related to a specific instance of a class. So we've created a new data type, the car data type, and since it's a data type, we can use it just like we would any data type in our system. So if I wanted to create a little method here, private static, and I'll use the decimal data type because I'm working with going to work with dollars or money, currency, and I'm going to create a method called determine market value. All right, and I'm going to allow this to accept a car as an input parameter. And what I'll do is just, in this case, I'm just going to hard code car value to $100. Okay, and we'll leave it at that. In fact, I'll go ahead and add the M here. However, if this was a real application, someday I might look up the car online using some sort of a web service to get a more accurate value. Okay, accurate value. But for today, we're just going to hard code the value to be 100, and we'll return car value. Okay, and so here I can go determine market value. I can pass in my car, and I should return back a value. So let's go decimal value equals determine market value, and then let's go console.write line, and we'll use what we learned previously to print out the value of the car, like so. And let's run the application. And you can see that it's worth $100. All right. Now notice what I did here. I used an uppercase C in car and a lowercase c in car. The uppercase C corresponds to the name of the class because I named it with a capital C. And the C# compiler is smart enough to know that, again, capital C car and lowercase c car are two different things. And this is a common naming convention to use the same name for an object if there's no reason not to, if there wasn't something special about the car, like it being in some special state. But I can reuse the word car. I chose not to do that here just to make it obvious what I was actually doing, but there's nothing wrong with doing this as well, defining this input parameter's data type and then giving that input parameter the same name but just with a lowercase character. They're two very different things. Okay, so moving on, I want to talk about creating methods on the class. We've already said that that classes are containers for methods. So we've created this helper method here inside of my static void main, but it might make more sense for us to create that method here inside of the car class itself, since the car class already has access to information like the make, model, the year, and the color, right? And that's the kind of information that we would use in making a determination on its value. So here, let's go ahead and define this as a public decimal determine market value. Now we're not going to allow anything to be passed in because we already have all the information we need right here. Okay, so let's create a little algorithm here. So if the year is greater than 1990, then we will set the value of the car's value, which we need to define as a, so let's go decimal car value. We'll set the car value equal to $10,000. So if it's a relatively new car, we'll set it to $10,000. Otherwise, we'll say the car's value is only worth $2,000. All right. So this is a very, very overly simplistic example, but we just want to demonstrate the fact that Inside of an instance of the class, you're going to be able to access its properties, okay? So we're able to access the current car's year in order to determine its value. And so in this case, what I'll do is let's comment this out. And we'll comment that out. And here we'll go console.writeLine mycar.determine market value, like so. And because this is going to come back as a decimal, I'm still going to want to format it. All right. So now let's go ahead and run the application. All right, and since it's in 1986, it's before 1990, it's only worth $2,000, okay? So in this lesson, we used a very concrete example. We've all seen cars, driven cars, owned cars, okay? A car is easy to conceptualize and represent in a class because there's a tangible real-world equivalent. Now, my assumption again is that your main exposure to classes will be whenever you're using classes defined by Microsoft in the .NET Framework class library. And most of the time, those classes don't represent real tangible things. They're very conceptual in nature. You might have a class that represents a connection to the internet. You might have a class that represents a buffer of information that's streaming from a hard drive, okay? They don't really have real-world tangible equivalents, so you need to be aware of that. In most cases, the .NET Framework class library classes don't have real-world equivalents, but the ideas are exactly the same. As you mature as a software developer, you might want to invest a little bit more time in learning how to create your own library of classes. And those classes can interact with each other. They can represent real things in your company or in the real world or conceptual things. The process that you go through to break down a problem in the real world and represent it in objects is object-oriented analysis and design. Again, that's not a topic that we're going to cover in this series of lessons, but you can learn more about that at devu.com, where I spend a lot of time talking about those sorts of things. Okay, so to recap, a class is just a data type in .NET, and it's similar to any other data type, like a string or an integer. It just allows you to define additional properties and methods. So you can define a custom class with properties and methods, and then you create instances of those classes. Or rather, you create an instance of a class, therefore working with an object using the new operator. You can then access that object's properties and methods using the dot operator, the member accessor operator, right? So there's quite a bit more to say about classes. Don't worry if you don't understand everything just yet, why you even need them, how to really fully utilize them. Just make sure you understand the process that we went through in this lesson of defining a new class, creating an instance of a class, setting its properties, getting its properties, passing an instance of a class into a method, or even defining the method inside the class itself and allowing it to access its own members, like its other properties, okay? So if you really don't understand much more than that, then you're doing just fine. You're exactly where you need to be. Don't worry. We'll cover lots of other topics related to this in the upcoming lessons. We'll see you there. Thank you. Hi, I'm Bob Tabor with Developer University. For more of my training videos for beginners, please visit me at devu.com. In this lesson, we'll continue to talk about classes and methods. We'll begin by talking about the lifetime of objects. So objects come to life, they live for a period of time, and then they die. They're removed from memory. And we'll talk about the .NET Framework runtime and its role in the creation, the maintenance, and then ultimately the removal of objects from memory. Next, we'll talk about constructors, which are simply methods that allow us to write code as developers at the moment when a new instance of a class is created. And then finally, we'll talk about static methods and properties. That static keyword's been lingering around now for some time, and we've been using static properties and static methods throughout this course, even from our very first example. So we'll finally tackle that issue in this lesson. All right, so let's begin by creating a new project. You can see I've already done that. You can pause the video and catch up to where I'm at right now. I've created a new project called Object Lifetime. Furthermore, you'll see that I copied the car definition from our previous lesson. If you like, you can type that in, help build some muscle memory, help remind you to use the prop tab shortcut, the code snippet in Visual Studio to create these shortened auto-implemented versions of properties. We'll talk about that in a little while. And then ultimately, you can see in line number 13, we create a new instance of our car class. That new instance we'll call myCar. And we talked about this in the previous lesson, but I felt like this deserved a little bit more explanation because there is actually a lot that's going on under the hood, and it would be helpful to understand this as we begin to work with classes and objects. So whenever we issue a command to create a new instance of a class like we have in line number 13, the .NET Framework runtime has to go out and create a spot in the computer's memory that's large enough to hold a new instance of the car class. Now that much we know. The computer's memory has addresses that are similar to street addresses, like the address you live at, the address that I live at. Now admittedly, a computer's memory addresses look dramatically different than our addresses, like 123 East Main Street, because the computer's addresses are typically represented in hexadecimal values, but they're known addresses nonetheless, and it's easy then for the computer to find something in its memory by using its address. So the .NET Framework's first job is to find an empty available address where nothing is currently living, where there's no data that's currently being stored, and that address has to be large enough to store an instance of our class. So the .NET Framework runtime will then create the object instance, and it will copy any of its values that are currently stored in that object instance up into that memory address. Then it takes note of where it put that object. It notes the address of the memory where it put that instance of our object, and then it serves that address back to us, and we store that address in the actual name of, or the instance name of our class, in this case myCar. That variable is actually holding on to a reference, or in other words an address in the computer's memory where we can access that object once again. Now whenever we need to access the new instance of the car class, we merely can use its reference name. It's in this case myCar. So myCar is simply holding an address. It's simply a reference to an instance of, in this case, a car class in the computer's memory. Whenever you need to work with that instance of the car class, you just use the myCar identifier, and the .NET Framework class library, the .NET Framework runtime takes care of everything else for you. It gives you the illusion that you're actually working with the object itself, but in reality, you're just holding on to a reference to an address in the computer's memory. Now there's an analogy that helps me to sort all this out in my mind, and we're going to continue to extend that bucket analogy. If that object is stored in the computer's memory, and if it's what we have equated to a bucket, an address, an area that holds on to our values, then what's returned back to us as programmers is a handle. That's what myCar is. It's our handle to the bucket. And we've used that bucket analogy a number of different times, and it's served us well. But we essentially are storing values in that bucket, just like we were before, and we're holding on to that bucket using our reference to that memory area in our computer's memory. So what happens if we were to let go of the handle? Well, at that point, we'll no longer be able to get back to the bucket. We've lost the bucket somewhere in the computer's memory. The bucket will no longer be accessible to us. Now, can we ever get back to that bucket? Well, no. What happens is that the .NET Framework runtime will be constantly monitoring the memory that it manages, and it's looking for objects that no longer have any handles associated with them. So once we let go of a handle, the reference count, the handle count, I guess you could call it, will go to 0. And at that point, the .NET Framework runtime will say, I see that nobody's interested in you anymore. They've let all of their handles to you expire or to go out of scope. So that must mean that you're no longer needed, and it removes it and throws it in the garbage. And so that process of monitoring memory, looking for objects that no longer have any references to them, is called garbage collection. It's one of the core features of the .NET Framework runtime. And it's one of the reasons why it's easier to work with C# at first as a developer than maybe going directly to C++. In an unmanaged language like C++, you, the developer, may have to manage memory on your own, and sometimes you might forget that you actually are leaving things in memory and you're not cleaning them up, you're not removing them yourself, so your application might have a memory leak. Or you might have a corrupted memory region where you're using an area of memory and you forget that you're using it, so you copy something else to that area of memory. Now you go back to retrieve the value that you originally put in there, and it's corrupted. So that leads to corrupted memory in applications. You don't really get that issue so much in C# because, again, the .NET Framework runtime takes care of all the memory management for you. All right, so let's do a little experiment here. If we said that we can have one handle to a bucket, what happens if we attempt to create a second handle to the same bucket? So let me do this real quick. Let me go to my car and start setting some of the properties, like the make equals Oldsmobile. Then we'll set the model equal to the Cutlass Supreme. And then we'll set the year equal to 1986. And then finally, we'll set the color to silver. All right, now keep that in mind. We've created a new object called that we're referencing using the myCar identifier. This car class instance of the car class lives in memory, and we're holding on to it with a handle called myCar. But what if we were to create another car like this? So my other car. What have we really done right now? We simply have created a handle, but we've not attached it to any buckets of cars in our computer's memory. So at this point, what I could do is go my other car equals my car. Now, what have we really done there? Well, we've merely taken one handle to a bucket in memory, and we've created a second handle and said, hey, let me copy your address, so that we're both referencing the same bucket in the computer's memory. Now, to prove that, what I'll do is do a console.writeLine, and we will do what we did before. Whoops. All right, and just give me a second here. And we'll reference my other car's make, my other car's model, my other car's year, and then my other car's color. Let me separate these to different lines for readability's sake, like so. Whoops. All right, and then a console.readLine for good measure. Now let's run the application. All right, and you can see that even though we created or set the properties of my car, since we copied the reference to the car object in the computer's memory into a new variable called my other car, I can still get to the values that are in memory because they're both pointed to the same object, right? And now I can even do something like this, where I actually change something. My other car dot, let's set the model equal to the 98. That was the large style model for that car. And let's then go back to and do something similar to this, just to prove that they're one and the same here. And I'll say, hey, let's do that, okay? So we're going to use our reference called my other car and set the model, change the model from the value Cutlass Supreme to the 98, and then we're going to say, hey, show me what's in the my car object. All right, so now we're going to run the application, and you can see now we're printing out what's currently in my car. It's the same thing that we changed in my other car because they're both pointed to the same place. I just want to emphatically make that point here. All right. Okay, so as you can see, we have now two references to the same object in memory. We essentially attached a second handle to the same bucket so that we can use either one to retrieve the data in the bucket, so to speak. All right. If you don't like that analogy, maybe it helps to think of this in terms of balloons. So I have a balloon and I have two strings tied to the balloon. What happens when I cut the first string? I'm still holding on to the balloon, but what happens when I cut the second string? The balloon now will fly away and we'll never see it ever again, okay? So as references go out of scope, in other words, whenever the current thread of execution leaves the current code block that we're currently in, or those object references are set to null intentionally by the software developer, then the number of references to the object, the number of handles to the bucket, the number of strings attached to the balloon, they go to 0. And so here again, when the .NET Framework runtime looks through memory and finds objects that have a reference count of 0, it will remove those objects from memory. So we talked about the two instances in which the connections to the object get removed. One is that the reference goes out of scope. So whenever we create a new variable called my car, it will continue to be in scope as long as we're inside of this main method. But once we exit out of the main method, that variable goes out of scope. It's no longer available for us to access any longer. The same would be true if we created a method, a different method, and defined a variable. And as soon as we go out of scope of that method and we have finished executing all the lines of code in that method, then any of the variables that were declared inside of that method go out of scope. And in this case, we would lose then any references to the objects that we created in the context of that method. All right. So that's one instance in which we'll lose references to objects that we've created. But the second is if we, as the developers, actively take a role in cutting the strings or removing the handles from the buckets in memory. And the way that we do that is by setting our objects equal to null. The value null is not 0 and it's not an empty string. It just means indeterminate. In this case, what we'll do is go here and we'll set my other car equal to null, like so. And when we do this, now we'll remove one of the handles to the bucket, so we're back to just one handle in the bucket. To prove this, let me go ahead and copy this little section of code and go here and put it below this. And when I do that, notice what happens. We'll get an exception. The exception is that there's a null reference exception that was unhandled. And the reason why it was a null reference exception is because we have now removed the handle. The handle does not point to any objects in memory, and yet we're still attempting to access values from the object in memory, so we get an exception in our application. All right. Now, what were to happen if we were to remove the second reference, like so, my car equals null? All right. Well, at that point now, we have removed all the references to the bucket. Even if we were to attempt to get to it with either my other car or my car, either way, the references are gone completely. And so now the object will be removed at some indeterminate time in the future by the .NET Framework runtime. And so in some situations, this indeterminate period of time can cause a problem, especially when the object in memory is holding on to some special resource, maybe something like a reference to a network connection or a file on the file system, or holding on to a handle to access a given database. So again, we don't know exactly when the .NET Framework runtime will actually execute the garbage collection step, and that might pose a problem in certain situations. In these cases, you would want to use a more deterministic approach to requesting that .NET removes the object from memory and, if necessary, will finalize and clean up anything that needs to happen inside of that object to completely get rid of it in the computer's memory. So in these cases, you want to learn about deterministic finalization. That's a little bit of an advanced topic, so we're not going to talk about it in this series of lessons. Just keep in mind that whenever we set reference to null, or whenever we go out of scope, we will be removing all the references to our objects, but the .NET Framework runtime itself figures out when it's ready and willing to remove those objects from memory completely. In most cases, that's not a problem. Occasionally, you're going to run into a situation where it is a problem. Know that there is a remedy for it called deterministic finalization. Okay, so that should suffice our explanation of really what's going on whenever we create new instances of objects, how objects are maintained in memory, and then at what point they're removed from memory. So let's move on and talk about constructors. And I said at the very outset that a constructor is merely a method that allows us as developers to execute code at the moment that a new instance of a class is created. So there's something really subtle about what's going on here in this line of code, line number 13. Did you notice that whenever we use the new keyword and we give it the name of the class that we want to create a new instance of, that we're also calling it using the method invocation operator? Why do you suppose that is? Whether you realize it or not, you're calling a method whenever you create a new instance of a class, and that method is referred to as a constructor, and it allows you, the developer, the option. You don't have to do this, so it's an option to write some code at that very moment whenever a new instance of a class is created. So constructors can be used really for any purpose, but typically they're used in order to put that new object into a valid state, meaning that you can use it to initialize the values of the properties of that given object, and so it's immediately usable. Now, let me give you a really quick example here. Let's say that you want to create a constructor that would allow you to set a property of the car at the point whenever you create a new car class. So that property is available immediately in the very next line of code whenever we begin to work with it here in line number 15. So whenever you actually want to create a constructor, you would go and create something like this. Public car. And in this case, what I'm going to do is simply set the make property to Nissan. So by default, whenever we create a new car class, we're going to set one of its properties, the make property, to Nissan. All right. Now let me say this as well. You might see the keyword this used. The this keyword is optional. It refers to this instance of this object, and it's just to help clarify where this variable name or this name is coming from. When I see the this keyword, I automatically think, oh, that's part of the declaration of the class itself. It's saying that you want to access a member of this class that's been created, okay? But as you can see, it's kind of faded out in my text editor. It might not be in yours, which lets me know that I could actually remove this. It's not necessary, all right? So you might see that, though, in other people's code. Just understand what that is. All right, so now if we were to go ahead and create a new instance of the car class, here's what I'll do. I'll actually comment out all of this code, like so. And then I'll comment out the code that we know will break the application. Well, we can leave the rest of it, I suppose. Now, whenever we run the application, notice that the very first item that is displayed is the make of the car, and it's set to Nissan. So I didn't set any other properties. That's why we didn't get any other values there in the printout, but hopefully you can at least see how we go about creating constructors. Now, admittedly, it may not make a lot of sense right now why you'd want to do this, but I'm showing you the technique you'd use, not the rationale necessarily. But the rationale is simple. What we would typically do here is to put any new instance of an object into a valid state. So you could load values into the various properties of your class from a configuration file or from a database or some other place in order, again, to get that object into a valid state so that it's immediately usable at the point of whenever it's instantiated. All right. So let's go ahead and talk about overloaded constructors. You'll see this frequently whenever working with objects in the .NET Framework class library. So just like you can create an overloaded method in your classes by changing the method's signature, in other words, the number and the data type of the input parameters for the method, you can do the same thing with a constructor. You can create an overloaded constructor. So what I'm going to do is create an overloaded constructor here, like so. Now, at this point, the method signatures are the same, so I'm going to get a little error here. But to modify that, I will merely add at least one input parameter of type string. But I'll go ahead and do them all as well. So, and then here in the body of the constructor, I would just do make equals make. So this capital M make is in reference to the property itself. This lowercase m in make is the name of the input parameter. It's a good convention to use the same name for readability's sake and for your own sanity. You don't have to do it this way, but just keep in mind that uppercase m and lowercase m are create two different items in as far as C# is concerned. Okay, so it's not confused. You might be confused, but it will be able to handle this just fine. Okay. Now you might ask, well, what's the point of that? Well, in many cases, whenever you create a new instance of a class, typically you don't want to take 5 steps to do this. You would want to immediately, whenever you create a new instance of a class, so car, my third car equals new car, at this point you can do one of two things. Notice here that underneath car, underneath the open parenthesis, I have one of two ways that I can call the constructor. I can either give it no input parameters, or I can give it 4 strings as input parameters to initialize that new instance of car and put it into a valid state immediately. So here I might go Ford Escape 2005 white, like so. And now I have not only created a new instance of the car class, but I've immediately initialized its values by calling its overloaded constructor to populate all of its values at the moment of instantiation. All right. So what were to happen if we were to actually remove these two completely? What if we were to comment these out? What happens? So you can see that we're still using the method invocation operator for our new instance of car. That would suggest that we're calling a constructor, but we don't have a constructor defined. So why is this working? Why isn't it giving us an error? Well, the reason is because a default constructor is automatically created for you whenever you compile your classes. It will be a constructor without any input parameters, and it will have no body. But it's essentially the equivalent of doing this right here, except with nothing inside of it. All right, so that's created automatically for you. So no matter what, you're going to have a constructor. It just won't do anything for you. The implicit default constructor has no input parameters, no method body, but it allows you to make calls and create new instances of classes in a consistent way. So it's actually just generated for you, again, at compile time. Of course, by defining it yourself, you're taking control of the process of instantiation. All right, so let's talk about the static keyword now. You've seen static around since the very beginning. I said let's ignore that for now. We created our own methods, and I said we have to use the keyword static. I'll explain later. Well, now is the time. So I want to ask a question. Did you ever notice that whenever we were working with the console window, we never had to create an instance of console, the console class, in order to call its methods, right? And that it combined with the fact that whenever we wanted to work with date time, we could get to this moment in time by using the datetime.now property, but we never had to create an instance of datetime. Furthermore, whenever we were actually working with arrays and we wanted to call the reverse method, do you remember we did array.reverse and then we passed in the array itself? How is it that we were able to use the reverse method without creating an instance of the array class? Well, in each of these cases, the creators of those classes, or specifically those methods, adorned their methods with the keyword static, which means that you do not have to create an instance of the class in order to utilize that method. In some cases, they may have defined an entire class as static, meaning that all of its properties and methods were static. So you can create your own static methods and classes as well. Again, the objective here at the very outset is to just help you utilize the .NET Framework class library. So just know that some of the classes and methods in the .NET Framework class library are static, and some are instance, or require you to create an instance of the class before you call its methods and properties. All right. So the static methods will be available to you without first requiring you to create an instance of a class. So just so you can see how this works, we can create a static method on our car class, like so. In this case, we'll go public static void my method. And here we'll do console.write line called static my method. All right. And now we can go here near the very top and just say car.myMethod. And notice I didn't have to create an instance of car. I'm using the actual car class definition itself when we run the application. All right, and before we go too far here, let's comment out pretty much everything. Let's remove that, and we'll go down here. All right, just make this so that we don't run into any potential issues here. So let's run the application, and you can see that we were able to successfully call the static my method. Now, what would happen if we attempted to reference one of the properties in our class? So let's just print out the make property. Notice that I immediately get a red squiggly line beneath the word make. It says that an object reference is required for the non-static field method or property called car.make. So it's important to keep in mind that there's a fundamental difference between working with classes that have static members versus instance members. Instance members are the things like we've been working up to this point, where we have a series of properties that describe a single instance of a given entity, like a car. There might be methods that operate on a single instance of a car, like the constructors that we saw. Whereas a static member, like a static method in this case, they don't really operate on any single instance. They're more like utilities. You can call them at any time. They don't depend on the state of a given instance of the class. or even the application itself. They can be used at any time because they're not really tied to one specific car. They're true of all cars and can be used at any time. All right, so static members versus instance members. Just keep those two clean in your mind. Now, you might want to ask the question, why would you ever create a static member like a static method? Well, that's a bit more complicated. That might require a longer discussion of things like design patterns, which are common solutions to common problems for software developers, or coding heuristics, which are more the best ways to go about solving problems. I just want you to know that there's a fundamental difference between static members in a class and instance members of a class, and it's easy to recognize them. If it's a static member, it'll have the static keyword, okay? And in which case, you cannot reference any instance members, like instance properties or even other instance methods that act on instance properties, all right? They require an instance of the class to operate. So just know that there are these two types of members in a given class, and that you're going to encounter both whenever you're working with the .NET Framework-based the class library. And why you would use one or the other, well, that's really, again, another story. I would say this, that typically I would recommend that you don't mix and match them in the same class. Clearly not everybody agrees with me, because you'll find that many times. But it's not really important at this point to understand why you would use one over the other. Just know that that possibility exists. That's why you don't always have to create an instance of a class before you use the members of its class. In this case, a given method. All right, so let's recap what we talked about in this lesson. We began talking about the lifetime of an object, how we create a new instance of an object, what that's doing in terms of creating an area in the computer's memory, returning back to us an address, a reference to that object in memory, what happens during the lifetime of that object, and ultimately what happens whenever we remove all of the references to that object. We talked about the role of the .NET Framework runtime and how it's keeping track of the number of references to objects so that it can perform garbage collection on objects that have no more references to them in memory, as a means of keeping things clean and making the memory available to other applications, or even our application again. We talked about constructors and how developers can use them to put a new instance of an object into a valid state at the point when that object is created. Then we talked about the static keyword. We looked at some usages of static members inside of the .NET Framework class library. We looked at creating our own static member, this main or this my method. We talked about the difference between static members and instance members and how it's really oil and water. You can't mix the two, and why that is. We didn't really talk about why you would choose to use one over the other. However, that's, again, a topic for another day. So hopefully all of these concepts make sense. If not, don't continue on and hoping that you'll just catch up to them at some point in the future. Make sure you thoroughly understand this before you continue on. Okay? If you are continuing, great. We'll see you in the next lesson. We'll see you there. Thanks. Hi, I'm Bob Tabor with Developer University. For more of my training videos for beginners, please visit me at devu.com. Now, we haven't spent a lot of time talking about variable scope. It's actually extremely important. We recently learned that it also impacts the lifetime of objects, so we want to spend a little bit more time really making sure we understand the scope of the variables, whether they be variables holding simple types or references to complex types in our applications. And not only do I want to fully explain that, but then I want to use that as a launching pad to explain keywords like public and private that we've seen several times in our course up to this point, but I haven't really talked about. Before we talk about that, let's talk about variable scope. So let me start by saying that whenever you declare a variable inside of a block of code, that variable is only alive for the life of that code block and any of its code blocks, any of the interior code blocks or code blocks inside of that code block. Meaning that when the code block is finished executing, the variable that was defined inside of that code block is no longer accessible, and its values are disposed of by the .NET Framework runtime. So we'll start by looking at how that is impacted by common code blocks that we've been working with up to this point, and then we'll use that and expand beyond there. So you can see that I've created a project called Understanding Scope, and you can pause the video and catch up with me. I want to create this project and focus on testing how variable scope works. And so I'll start with a pretty simple code example. Again, the concepts that we talk about also apply to object references, not just variables that hold simple strings and integers. All right, so let's start by creating a simple for iteration statement, and we'll just loop through 10 times, and we'll do a console.writeLine containing the value of I. And then here we'll do console.readLine so we can see our results, and we'll run the application, and as we would expect, we can see values from 0 through 9. Now, what if I wanted to access the value of I here right after the closing curly brace for the for statement? We'll notice that I'll get a red squiggly line under I, and if I hover my mouse cursor over it, it says that I does not exist in the current context. Why? Because I is now outside of the scope of its definition. We defined I inside of the for loop. It's available inside the for statement itself plus in the code block below it, but not outside of either of those. All right, so we'll have to comment that out. So second, let's start, we'll continue by going and creating a string of j equals empty string. And what we'll do inside of our loop here is just go j equals I.toString. Now let's go outside of our loop. Will we be able to access the value of j? So let's go outside of the for, and will we be able to actually print to screen the value of j? All right, we are not getting any errors, so let's run the application. And you can see that the last value that was inserted into j was the value 9. Since we defined j outside of the scope of this code block, of the for statement and its code block, we can access it inside of that code block and outside of that code block as well. All right. Next up, let's look at at something like this, where we'll actually create what's called a field or a private field. So we'll go private static string k equals, and a private field is sort of like a property, except it's private in nature, but it is available to all of the members of the class. So we should be able to see k inside of our for loop. So let's do I.toString. We should be able to see it here as well in the outside of the for loop, like so. Let's go ahead and run the application, and you can see that second console.writeLine will also display the number 9. But the real question is, what if we were to create a helper method, static void, and we'll just call this helper method. And here we'll go console.writeLine, and we'll say this is the value of k from the helper method, and we'll do that. Now here we'll call the helper method like so. Will this work? Will we be able to access the value of k as it was set inside of our for loop outside of our static void main? Let's run the application, and you can see that we can in fact get the value of k from the helper method. Why? Because k was defined at I guess you could say, the class level. It is a sibling to static void main and static void helper method. Therefore, it's accessible to each of these as well as any of their inner code blocks. All right, hopefully this is starting to make sense. Let's go inside of the for loop now, and here what we'll do is a simple if statement. So if I is equal to 9, so on the very last run of this, then let's declare a string called L, and we'll set that to string, the I to string, and then outside of that we'll go console.writeLine the value of L, and as you might anticipate, we will see that L does not exist in the current context. Why? Because we declared the value of the string variable L inside of the if statement's curly braces. Outside of those curly braces, it's no longer accessible, so we have to comment that out. All right? So hopefully this solidified in your mind many of the combinations that we can use in determining whether something's in scope or out of scope. And if you had any confusion about this, hopefully that cleared it up a little bit. All right, so now let's move on to the larger topic of accessibility modifiers. We've been creating classes, specifically the car class up to this point, and whenever we were creating methods, I would typically use the public keyword. Occasionally I would use the keyword private like I did here in line number 11. Private and public are both accessibility modifiers. They're used to implement a tenet of object-oriented programming called encapsulation, which is actually pretty important. So in a nutshell, you should think of classes as black boxes. And whenever you think of a black box, maybe you can think of like one of those old style television sets. Maybe your parents or grandparents had one. I remember as a kid us having one. There were no remote controls. You had to get up, walk across the room, and actually turn the dials of the TV in order to tune to either VHF or UHF channels. You had another volume maybe or a dial where you would adjust the volume. You had an antenna in the back, so you would connect this wire out to your antenna, and you had another one where you would plug it into the wall. And everything else about the television was self-contained. Now, as a kid, I was fascinated whenever my dad would pop off the back of the television set, and he'd go and try to fix it by changing out the tubes. And it's always seemed like magic to me because I knew absolutely nothing about the innards of televisions. All I knew were the public interfaces, the button for on-off, the dials to turn the channel, the dial to turn the volume up and down, the antenna, whatever that did, and the little plug that would obviously give it electricity. But frankly, in order to use the television set, that's all you really needed to know, right? You did not have to know anything about how a television worked. All you really needed to know was how to plug it in and change channels, turn it on and off, and then adjust its volume. And that is exactly how your classes should be treated. All the important behind-the-scenes functionality should be encapsulated behind interfaces like public methods and public properties. Now, classes might, in fact, have private fields like we looked at here in line number 11, or they might have private methods that are used behind the scenes to enable all the magic that goes on inside of that class. But the consumer of the class shouldn't know anything about the inner workings of the class in order to work with the class, to operate the class. All they need to know is what's publicly exposed through the public properties and public methods. So in a nutshell, private means that a method can be called by any other method inside of the same class. So I've used the term private helper method a number of times accidentally. Essentially, when I use the term private helper method, I'm talking about a private method that adds some additional functionality to those public methods that are exposed to anybody who needs to work with the class through that method. A public method is what's actually going to be then called by somebody outside of the class, some other code outside of the given class. And private methods are only going to be called by members inside of the class, okay? So let me do this. I'm going to paste in some code to recreate our car class. And here I have a public and a private method. The public method is called do something, and the private method is called just helper method. All right, and these are not very interesting examples. I want to keep this as simple as possible. Now, from the outside of this car class, let's just kind of roll this whole thing up here and save it. And now whenever I want to go here inside of my static void main, I might want to work with the car class. So I'll go car, my car equals new car. And then I'll do my car dot, and notice that I can only see the public method do something. Now, I might happen to know there are other methods also inside this class, but I can't see them from outside. Their visibility is hidden to me because they're marked as private. All I really need to know is how to use the do something method, and if I understand that I can call that, all the implementation details will be hidden from me, but it'll work as I expect it to work. Here you can see that it merely prints out the words hello world. All right. Now, how it does that, whose responsibility inside of the class it is to actually display that, that's none of my concern. All I need to know is how to call the public method do something. Okay. So in a sense, the consumer of the car class has absolutely no idea that that helper method even exists. All it really knows is that there's one public method, and it could call that public method, but it doesn't know any of the hairy implementation details, right? Now, I use the term in a sense, that in a sense, the consumer of the car, the consumer is going to be a software developer, and a software developer is going to be able to drill in and say, oh, I see how it's doing its work. It's actually making a call out to this other private helper method. And so, you know, there is a sense in which it is public to developers, but it's private from the perspective of the consumer, which is this main method. It can only see the do something method, not the private helper method. Okay, that's all we really mean here. Now, admittedly, this is extremely mundane. It's a simple example that's only real value is to illustrate the notion of encapsulation, that we typically want to hide the implementation of our classes behind well-known public interfaces, in this case, a friendly method called do something. And the purpose of this lesson is to better understand the notion of scope, because we said that once variables, especially variables that contain object references, fall out of scope, their objects will be garbage collected. Furthermore, it's important to understand that there are parts of classes that you have access to and parts of classes that you don't have access to. Now, if you ever decide that you want to create your own custom classes someday, even a library of classes that represent the business domain of your company or of your specific application, it could be a game, you should strive to expose public methods and give a simple, straightforward, obvious way to call the public methods from your class, but keep all the other helper method, all the other internals privately tucked away and not available to prying eyes. So you don't want a developer to simply go fiddling around inside of all of your methods and use your class in a way in which it was unintended. You want to give them a way to use your class properly through the methods that you've designed and that you've made available through public interfaces. And this also will help to remove any ambiguity in the usage of your classes. And it should be much cleaner as well. All of these things were under consideration whenever the developers built the .NET Framework class library. In the .NET Framework class library, methods and properties are exposed using the public keyword. Now, they might also be using private fields and private methods behind the scenes, but you would never know. They may use other types of accessibility modifiers as well. There's actually a couple available called protected and internal. However, these are primarily for whenever you're working either in a rich inheritance relationship between classes and you're building a rich inheritance hierarchy between classes, or whenever you're working with a very large library that's compiled into separate assemblies. That's when some of these other accessibility modifiers might come into play. They're topics that are beyond the scope of this absolute beginner series, but topics that I do cover on Developer University. So if you want to know more about object-oriented programming and encapsulation, by all means, go ahead and... All right, we are well past halfway through this course. You're doing great. We've already covered the most difficult material already. Now we're just adding on details. So you should be encouraged by that you're still plugging away at this. And you're doing great. We'll see you in the next lesson. Thank you. Hi, I'm Bob Tabor with Developer University. For more of my training videos for beginners, please visit me at devu.com. Previously in this course, I said that the .NET Framework class library is merely a collection of classes, each containing methods filled with functionality that we can utilize in our applications, but we didn't have to write. Microsoft has spent tens of thousands of man-hours building and maintaining this library of code, and we can benefit from it by merely calling into its classes and methods inside of our applications. Now, the Framework class library is massive. Thousands of classes, each with their own set of methods. And so the developers of the Framework class library wisely decided to split this library of code up into multiple files. Just imagine if you had to load the entire library into memory every time you wanted to run your application. First of all, it would be excruciatingly slow, and then secondly, it would probably take up the majority of your computer's memory. And so they split up the code into multiple files. These code files are called .NET assemblies. In fact, even the applications that we build, they're ultimately compiling into .NET assemblies. As you can see, I have a new project called Assemblies and Namespaces already open. I've added 2 lines of code. If you want to pause the video and catch up, that would be great. In lines 13 and 14, I'm merely printing hello world to the screen and then pausing the execution of the application. However, even in this application, a executable .NET assembly is being generated the very first time that we run the application while we're debugging. So now, if you want to take a look at what happens, go to your projects directory, and inside of the project folder, you'll see that there's a bin directory. We avoided this very early in this course, but now I want to talk about it briefly. The bin directory will contain both a debug and a release version, ultimately a release version. The debug version will contain additional files required by Visual Studio to connect to the execution of the compiled executable. This allows us to step through the execution and pause the execution line by line in the Visual Studio debugger. Now we can additionally then, after we've created our application and thoroughly debugged it, we can say I want to create a release version of the application, then go to Build Solution in the Build menu, and it will create a version of our application without any of those debugging symbols, without that connection to the debugger. If you look at the file system, you might be a little confused to see that it also has a lot of those extra files in there, but they're basically ignored. But that is what's going on behind the scenes. Notice that in each of these cases, we're building an executable file that will run, and we could even just double click it and run the application from here like we did before, right? Now that is different from the type of .NET assembly that allows you to create a library of code that can be shared across multiple projects. In that case, you'd be compiling a project into a .dll file extension. And we can create a code library. I'll show you how to do that in another video. But at any rate, the .NET framework has to already be installed on any computer where you want your application to work or to run. Fortunately, basically every copy of Windows already has the .NET Framework runtime and the class libraries installed in a location that's globally accessible called the Global Assembly Cache. And so every .NET application can reference the same set of assemblies in that one spot on your hard drive. Now you might say that whenever you build your application and set up your application, you may not realize that by choosing to create a file new project and then selecting the console window project template, you were actually creating references to those files in the .NET Framework class library. That's one of the functions of the setup routine for a project template. So if you take a look at the references node underneath your project in the Solution Explorer over here on the right hand side, you'll see that there are some references already to these things like system, system.core, system.data, system.net, and so on. All right. Now, we'll talk about what these are in just a moment, but that's indicative of the fact that we have references into files of the .NET Framework class library that the creator of the console window application thought we might find useful at some point. All right, so we'll come back to that in just a moment. Now, sometimes you'll need an assembly from the .NET Framework class library that has not been referenced, and I'll demonstrate how to do that in an upcoming lesson. Or perhaps you need to add a reference to an assembly created by a third party, maybe even yourself. I'll demonstrate not only how to create your own class library, but then also how to create references to third-party assemblies as well. Again, there are tens of thousands of classes defined in the full .NET Framework class library. In a few cases, the same class name was used, or at least there was the potential for it to be used. And so when that happened, the creators needed a way to be able to tell one class from a different class. And so they introduced the notion of namespaces. And namespaces are like last names for your classes. So think about your name or my name, for example. Somebody might say Bob loves coffee. And you might say, well, which Bob? There's like a billion Bobs in the world, right? But if somebody were to say Robert Theron Tabor likes coffee, well, that narrows it down. I'm pretty sure that I'm the only person in the world that has that combination of first, middle, and last name, all right? So I could either use the full name, Robert Theron Tabor, to reference one person, or once we understand the context of who we're talking about, maybe we're talking about only people in this room, then you might say, well, Bob likes coffee, he's the only Bob in this room, so they must be talking about Bob, right? So the same idea works with your code. We could use the full name of the classes that we need inside of our application. So for example, the full name of the console class is actually system.console.writeLine, all right, or the system.console class, right? That's the full name of the class, and then we're calling the method in that class. However, you'll notice that I didn't have to use the word system here. Why not? Well, because we used a using statement at the very outset of this code file, which says, I want you to look inside of these namespaces whenever you find a class reference that you don't recognize. And so the C# compiler, it finds the word console and it says, I wonder where that came from. And it begins to look through the namespaces listed in the code file, and it says, oh yeah, I found a class name called console inside of a namespace called system. All right, and so it thinks, all right, well, that must be the console class that he's talking about. Now, occasionally you might have two classes with the same name and you've added using statements for each of these inside of your code file. When that happens, you merely need to disambiguate by adding the full name of the class instead of relying simply on the using statement. Now you'll notice here that by default the program.cs file has a number of different using statements. In my text editor, they're kind of faded out a little bit, which indicates to me that they're not being utilized at this moment. So we could remove unused using statements from our code and our code will compile just fine. Again, this is a convenience for us that was set up for us by whoever created the project template for a console window application. So to further illustrate this idea, let's talk about how we can go about using the .NET Framework Class Library to do meaningful things, and how we would go about finding the source code or the classes we need to do something cool in our application. So for example, maybe I want to write data to a text file. How could I go about doing that? Well, I might open up Bing.com and I might search for, and I'm going to type in site Microsoft.com. So I'm going to limit the search results to just those that are returned by Microsoft.com. All right. This is going to help me find the documentation specifically created by Microsoft as opposed to third-party articles or whatever the case might be. So site:/Microsoft.com, and then I might just say write to a text file and then using C#, right? And so one of the top results are from msdn.microsoft.com, and MSDN stands for the Microsoft Developer Network. This is your primary source of information as a software developer on the Microsoft platform. And so in this case, here's a how-to article that will describe the code that we would need to write in order to write data to a file. Here's a long code example. In fact, it gives us 3 examples in one, and we could use one of these examples in our application in order to write data to a file. And we might decide to go ahead and use this second example. It comes close to what we want to work with here, and I copy it and paste it into my application. And I might remove some of the extra information here just because I don't need it. And I may need to modify this path. I believe I created a folder called Lesson 17 for this purpose. And notice that it's going to use a class name file and a method called writeAllText. Now in this particular case, notice that we already are given the full namespace of this file class, system.io.file. Now what we could do is actually remove that from here and go up and add a using statement for system.io, like so. All right, and notice that the compiler will find it and we'll be able to run our application. And got a little message there because I was in release mode. Let's go back to debug and start that over again. All right, and we don't get any feedback there, but if we were to open up our Lesson 17 folder, we would be able to find the text in a text file. Great. Okay, so now we can use that little snippet of code to do what we want to do. But notice it all started by searching on MSDN, finding a code snippet that we could use, and then we can modify it and add our own text here that we want to write this to our file, right? Okay, so that we start stitching things together. So that's one thing that one way that we can find the features inside of the .NET Framework Class Library that we need is to search on MSDN. Let's try one more quick example, and let's go back here, back to Bing.com, and here again I want to go site:/Microsoft.com, and then I want to do C# download HTML as a string, and I might find another reference. Now this is a different style of web page. There is one web page on MSDN for every class and every method in the .NET Framework Class Library. So in this case we're looking at a specific page for this download string method. And if you were to look at the remarks and some of the the syntax and some of the exceptions that it would throw, what we ultimately get to is a little snippet of code that we can copy and that we can paste inside of our application. Now notice what happens this time. It does not recognize the term web client. Why not? Well, we may not have the assembly referenced in our project, or we may have the assembly referenced, but we do not have a using statement that would include the web client class. So to remedy this, I'm going to hit Control period on my keyboard, and it says that it found this class in system.net. So we can automatically add a using statement for the system.net class by merely hitting the enter key on my keyboard, or I can just go ahead and say, let's go ahead and use the full name of the class here. I'll choose the first option using the arrow keys and then the enter key on my keyboard. Notice what happens. It adds a using statement for system.net, and then notice that the web client class is now found. It is obviously in a different color. There's no red squiggly lines, so it looks like it found the correct class that we're looking for. Now we merely need to give it a URL, so let's try msdn.microsoft.com, like so, and then we will just write this out to screen reply. And then we might even rework our application and attempt to save that into our text file as well. All right, so let's see what we get here. Hopefully this will work. We'll run the application. All right, it took a moment, but it loaded up a bunch of HTML into our console window. We can see the closing body and the closing HTML tag. Now if we were to go back to our folder and find our lesson 17 folder and open up our text file, we see here is the full web page that we scraped off of msdn.microsoft.com. Okay, so that pretty much wraps up what I wanted to say in this lesson. We are able to utilize the classes and methods in the .NET Framework class library, and we can find what we need by doing simple searches in bing.com using site:/microsoft.com to find the classes and the methods that we want to work with. Once we find those classes that we want to work with, and we find maybe even little code snippets, we can copy those into our program, and we may need to at that point fix the references to those classes. Now in this first case, remember that it gave us the full name of our file class, system.io.file, but in the second case we had to provide the using statement system.net in order for the compiler to find the class that we were wanting to reference and work with. And ultimately we did that with hitting Control period on the keyboard to add a using statement to the very top of our code. We talked about the purpose of namespaces to provide disambiguity between class names. We talked about the using statement as a way of creating a shortcut or a context and say we're not talking about every class in the .NET Framework class library. We're only talking about the classes that happen to be in these namespaces. So if you find, Mr. C# compiler, if you find a class that you don't recognize, look in those namespaces first before you complain. Okay, so we're going to continue on these ideas in the next lesson. We'll see you there. Thank you. Hi, I'm Bob Tabor with Developer University. For more of my training videos for beginners, please visit me at devview.com. Now previously I said that the creator of the console window application project template added references to those assemblies in the .NET Framework class library that we as developers might find useful for the majority of use cases. However, if we need an assembly containing some portion of the .NET Framework class library that has not already been added to our project, then we can simply add a reference to it. So this is one of 3 ways that we'll demonstrate on how to add a reference to an assembly. The first being an assembly from the .NET Framework class library. Now there's a number of different ways to go about this. The easiest way, I think, is to go to the Solution Explorer and then right-click on References and select Add Reference. And here you can see there are a series of, I guess, tabs along the left-hand side that would allow us to choose from the various types of assemblies that are available to us. We want to choose the framework, and these are all of the assemblies that are part of the .NET Framework class library. All right, now and you can see that there's already check marks next to a number of the system.this, system.that, system.net.http, and these contain a number of different classes, each with many methods, and these are just automatically accessible. If we needed something that is not contained here, then we could choose, for example, to just select a check mark next to the one that we want to add to our project, system.net, and click OK. And you can see that it's added a reference to system.net into our project in the Solution Explorer. Now we can reference any of the classes and utilize any of the methods in that particular assembly. Okay, so that's one way if we need to access some part of the .NET Framework class library. Now, in addition to that, there are libraries that are created both by Microsoft and there are libraries that are created by by open source contributors, other companies that are provided for free for very specific purposes in our applications. And so these are often common features that many applications need. That's why they've been open sourced. However, they're available through a special tool called NuGet, which is a repository that's maintained by a foundation supported by Microsoft, but ultimately its own entity. All right, and so there are a number of different ways to work with NuGet in Visual Studio. I'm going to choose the visual way to do it, and I find that to be the easiest for those who are just getting started and for me because I'm a more visual kind of person. There's also a textual almost command line style interface that would allow you to do similar sorts of things and even script these things. So let's go to the Tools menu and select NuGet Package Manager and then Manage NuGet Packages for Solution. This will open up a tab. Undoubtedly, no matter what you see on my screen, it'll look different on your screen because this is going under active development for the last few years, and it has changed frequently. Now, if there were a package that we wanted to add to our solution, we could simply search for it. Typically, we can learn about these sorts of things through blog posts and what have you. Say, for example, I wanted to access a database from my console window application and I wanted to use the Entity Framework API from Microsoft. It's available through, as a NuGet package, through this Manage NuGet Packages for Solution dialog. So I can select it. I can select it as one of the options. You can see it's one of the most frequently downloaded. Furthermore, I would then choose which project in my solution that I wanted to add it to, and I can choose the Install button. There's some other options as well. I'll leave you to investigate those on your own. I'm going to go ahead and click OK. I agree to the terms for using the Entity Framework. And in this particular case, it installed just a number of references to assemblies and copied them down locally to my computer. Now, depending on the type of package, it could not only contain .NET assemblies, but also sample source code files. It could actually run macros inside of Visual Studio. It could include things like style sheets and HTML and even graphical assets that it will include your project. So this is the second way that we can go about adding assemblies and more to our projects. But the third way that I want to talk about is whenever we want to add a reference to a class library that we've created. Now, we haven't created a class library up to this point, so this is a perfect opportunity to do that and then add a reference to it in our project. So what I'll do is start off by creating a new project. Let me go ahead and let you see my entire screen here. And in the new project dialog, I want to make sure to choose C#, and then I want to choose class library. Notice that I chose the one that doesn't have the little NuGet logo next to it. It's just a little, looks like several books and the C# logo. Now this will undoubtedly look different to you, but just make sure that it's a regular old class library. And here we're going to call this my code library and click OK. And I'm going to go ahead and say I don't really care to save my other solution there. All right, and so inside of this, you can see that I don't have a program.cs. All I have is a class1.cs. There's no static void main. And so what I'll call this is the scrape class, and we'll have one public method. So public string scrape web page, and we'll create a version of this where you provide it just the URL, and then we'll create a second version of this where you provide the URL and a file path. Okay. All right, and so in this first case, I'm just going to copy down some of the code that we worked with previously to create this functionality, where we were actually using this web client to go out, download a page, and then save it to a text file. I'm just going to generalize this. Remember what I did previously when I hit Control period on the keyboard in order to add a reference to system.net or add a using statement for system.net. And the next thing I'm going to do here is actually replace this hard-coded string with whatever gets passed in by the end user. All right, finally, I'm also going to have to add or resolve this reference to the file class. It's in the system.io namespace, so I'm going to add a using statement for that. However, in this specific case, I'm not going to write this to a file in this overloaded version of it. In fact, what I'll just do is return whatever's been input actually downloaded from client.downloadString. All right. Now the second version, we'll do something almost identical. Here, let me replace this with URL, and we'll get rid of console.writeLine, and we'll go ahead and write this to the file path that was passed in, and then we'll return the reply. Now, truth be told, this might be a good situation where I could actually take these lines of code and create a private helper method out of them, and maybe that's a good idea. Let's do that right now. Private string get web page. All right, and we'll pass in the URL, and so here and now both of these can just call get web page like so, and here we'll go string return or reply equals get web page. All right, see what I did there? How I was able to use a private helper method to encapsulate the functionality of actually getting the web page itself, and then in this case I was able to extend the scrape web page method to include writing that to an actual file path. All right, so now that I've created this, and let me go ahead and rename this file as well by right-clicking on it and selecting rename, and I'm going to choose to name this file scrape as well. I could name it anything I want. It won't matter because the name of the class itself is scrape. But at this point now, I'm going to go ahead and build the solution. It looks like it built. In fact, let me go ahead and build a release version of this. All right, great. So now let's open up a second version of Visual Studio, and I'm going to call this my client. So this will be a console application called my client, and we'll click OK. And what I want to do is to, first of all, add a reference to that DLL that we created just a moment ago. So I'm going to go and right-click on References and select Add a Reference. All right, so here I have some choices. Ideally, I would be able to look and find it in the same solution. We'll come back to that and do it in just a little bit here. But I may have to go and actually browse through the file system to find this, and unfortunately this is popping off the screen. However, hopefully we can work our way through this. And I'm going to navigate to the bin directory, into the release directory, and find my code library, and then I'm going to select the add button and then click OK. All right. And so now that I've done that, what I should be able to do is get to the scrape class, right? But it doesn't see the scrape class, so I'm going to hit Control period on my keyboard, and notice that it will find the correct using statement. The using my code library namespace scrape, my scrape equals new scrape. Okay, and now I should be able to go my scrape dot, and there we go, scrape web page, and I should be able to give it a URL. So let's go all right, and that should return a string. So string return, or actually just value equals, all right, let's move this over a little bit. And then I should be able to print that to screen. So console.write, like so. And now we should be able to run the application. And it takes a moment, but it pops up. All right, so what we're able to do there, well, we created a reusable library now, so whenever we want to scrape a web page, we can utilize this in any of our other projects. Now, did you find how inconvenient it was to actually go and search around whenever we wanted to add a reference to it? I had to go and browse through the through all my projects and everything. But I do want you to notice one thing about what happened after we did that. Let's go to my projects. And let's find that client, and let's navigate into the bin directory, and notice that it copied my code library.dll into the bin directory for the client application. So that's one of the things that it will do with any of the third-party assemblies that it will utilize. All right, but wouldn't it be easier if we were to start this over from scratch and we were to create a single solution that had both the client and the code library in the same solution? So let's do that now. I'm going to actually open up a third copy of Visual Studio. And here, let's create a new solution. So what I'm going to do is actually scroll all the way to the bottom and choose Other Project Types, and choose Visual Studio Solutions and find Blank Solution. Now this might be in a different place, so you may have to kind of hunt around for it, but you ultimately want to choose Blank Solution. It should be available to you. And we're going to call this Lesson 18. So the solution's name will be Lesson 18, but what we're going to do is add projects to this solution. So the first project that I'm going to add, and there's a number of ways to do this, like add, but it goes off to the right-hand side of the screen. I could add new project. File, add new project, and then we're going to choose the class library. So we'll call this the scrape library. All right, and then I'm going to choose to create another project and add it to our solution called of type console application, and this will be the scrape client. Okay. All right. So in our scrape library, what I'm going to do, just for simplicity's sake, is actually go to the work that we've done here a moment ago, and I'm going to copy all of this, like so. And let's come back here, and I want to paste all this in, like so. And yes, I'm going to have to resolve these class names by adding using statements here and here as well. All right, that should work. Looks like I actually lost my class name, so let's go public class grade. And then let's make sure to put everything inside of it. All right, there we go. Now we get it working. And I'll rename this as well to just scrape. I could have left it, called it class 1, but that'll work just fine. Okay, so I'm going to go ahead and build that. Right-clicked on the project name and selected build. All right. And now what I want to do in the client to utilize that class library is I need to add a reference to it. So here again, I'm going to right-click and select Add Reference, and this time I'm going to go to Projects, and notice if Solution is selected, the Scrape library will be an option. I'll choose that and click OK. And now we can utilize Scrape library in our application. So let's go ahead and just type in the word scrape scrape dot, and it's not going to find it. So I'm going to hit Control period, and I need to add a using statement. Since I renamed it, now it's called Scrape Library. So I'm going to add the Scrape Library namespace to using statement to the code file. So scrape my scrape. In fact, I don't have to do all that, right? I can just copy and paste it from the previous client, like so. And we can rerun the application. Whoops. And it says a project with an output type of class library cannot be started directly. All right. Why do you suppose that happened? Well, because there are actually 2 projects now in my solution, and you can't execute a library, correct? So what we need to do is right-click on the client project and select Set as Startup Project. And now, let's go ahead and close that. When we attempt to run the application, it'll work. Furthermore, if we were to make any changes to how the library actually works, let's say, what could we do here that's interesting? Let's do this. We'll make a change in one spot. And then I'll go content plus equals, that's all folks for the very end, all right, of that string that's returned. And I'll return content this time. All right, let's make sure we add everything there. So we've made a pretty big change to the application, and now when I run the application, it will recompile the DLL. It will add it to our project, and at the very end, it adds "that's all, folks." Okay, it's just the only thing I can think of off the top of my head. All right, so hopefully now you can see that there are several different ways to add assemblies. If it's part of the .NET Framework class library, then obviously there's a way to do that. If it's a free or open source package that's available from NuGet, we can use the NuGet Package Manager. Or we can create our own third-party class library and then add a reference to it by browsing. Or if we were to create the client and the library inside of the same solution, then we can reference it in the add reference dialog, but just under the project solution option. And we get the added benefit of being able to make updates, not having to go through 2 copies of Visual Studio to update it. It'll all be just, it'll update the next time we hit run. It'll recompile it and everything. Okay, so at any rate, that's pretty much it for this lesson. We'll continue on the next lesson. We'll see you there. Thanks. Hi, I'm Bob Tabor with Developer University. For more of my training videos for beginners, please visit me at devu.com. Previously, we looked at arrays, which allowed us to keep a sequence or a group of related data together inside of the same variable. So we would create an array by providing a data type, and so each item in the array had to be of that data type. We would also provide the number of elements we expected in the array by defining that number between a set of square brackets. Now that we have that predefined sized array, we could add items into each element of the array or retrieve values out of each of the elements of the array by indexing into the array using a zero-based index to index in and address one specific element of the array. Now, once we had the data collected into an array, we could do some interesting things. We could iterate through the array and investigate each element of the array. Or we could even pass the array around as if it were one variable, pass it in, for example, as an input parameter to a method. But you recall at that time I also said that at some point we would talk about collections. And I even gave collections a nickname, calling them arrays on steroids, all right? And I think you're going to agree after this lesson that collections are great whenever you're working with all data types, especially those data types, those custom data types that we've been working with up to this point in this series of lessons. For example, the car class that we created ourselves. Now, as far as the .NET Framework Class Library is concerned, it will often use both arrays and collections depending on the need, but I think you will